Okay, welcome back to DT tutorial where chemistry is made very simple and easy to learn. So in this video, we'll continue with our discussion on oxidation number of elements. And we have looked at rules in calculating oxidation number of elements. We have looked at the first rule, we have looked at the second rule, and now we are in the third rule. So the third rule states that the sum of the oxidation numbers of the elements in a compound is 0. The sum of the oxidation number of elements in a compound is 0. The sum of the oxidation number of the elements in a compound is 0. This simply means that when you add all the oxidation number of the elements in a compound, everything will be equal to 0. So the third rule states that the sum of the oxidation number of the elements in a compound is 0. So these are different compounds. What this third rule, rule 3, is trying to say is that if you sum up the oxidation number of all the elements here, they will be equivalent to 0. So the oxidation number of hydrogen plus the oxidation number of sulfur plus the oxidation number of oxygen, everything is equal to 0. The sum of the oxidation number of elements in a compound is 0. So the sum of the oxidation number here is equal to 0. So the sum of the oxidation number of sodium, of sulfur plus oxygen, everything will be equal to 0. The sum of the oxidation of calcium, of chlorine, of oxygen, everything here will be equal to 0. The sum of the oxidation number here also will be equal to 0. The sum of the oxidation number of hydrogen plus oxygen is equal to 0. Sum of the oxidation number here is equal to 0. Sum of the oxidation number here in ammonium is equal to 0. So the sum of the oxidation number of the elements in a compound is equal to 0. This is what rule 3 is all about. So to take us further, let's look at this question. In which of the following substances is the oxidation number not equal to 0? In which of the following substances is the oxidation number not equal to 0? So which of the following options is having an oxidation number not equal to 0? So the oxidation number of sodium tetrasulfate 6 is equal to 0. The oxidation number of sodium tricarbonate 4 is equal to 0. Why is it so? It is so according to rule 3 that states that the sum of the oxidation numbers of all the elements in a compound is equal to 0. So if you're having a compound, if you sum the oxidation number of sodium plus sulfur plus oxygen, everything will be equal to 0. So these two compounds, they are having oxidation number equal to 0. So the oxidation number of sodium is also equal to 0, and so it is not the answer. This is not the answer. This is not the answer. The oxidation number of sodium is equal to 0 because from 1 we stated that all elements in the uncombined state, that is in a free state, have an oxidation number of 0. So sodium here is uncombined. It is a free element just on its own, so it will have an oxidation number of 0. So for this substance, sodium ion, it will have an oxidation number equal to the charge. That is from rule 2, that the charge they possess is equal to the oxidation number. So the oxidation number of sodium here is, of this sodium ion, is plus 1. So in which of the following substances is the oxidation number not equal to 0? So it is option D. The oxidation number is plus 1. The rest are equal to 0. So the hallmark of this question is not equal to 0. Which of them is not equal to 0? So all of them are having an oxidation number of 0 except option D. It is the one not having an oxidation number equal to 0. So rule 3 is very important. The sum of the oxidation number of the elements in a compound is 0. The sum of the oxidation number of elements in a compound is 0. So let's look at this 2017 JAM question. The oxidation number of iodine in potassium iodate is A plus 7, B plus 3, C plus 5, and D plus 6. So what is the oxidation number of iodine in this compound, potassium iodate? So we must remember that we stated in rule 3 that the sum of the oxidation number of all the elements in a compound is equal to 0. So in other words, potassium, the oxidation number of potassium plus the oxidation number of iodine plus the oxidation number of oxygen, 3 molecules of oxygen, everything will be equal to 0. So what we've just done here is in accordance with rule 3. And rule 3 states that the sum of the oxidation number of the elements in a compound is 0. So everything in this compound, the sum of the oxidation number of everything in this compound, potassium iodide, potassium plus the oxidation number of iodine plus the oxidation number of oxygen, everything will be equal to 0. So what we're looking for in this question is the oxidation number of iodine in this compound, which is this iodine. So the question now is, what is the oxidation number of potassium and what is the oxidation number of oxygen? So with that, we can be able to deduce the oxidation number of this iodine. So before we go further, this is the periodic table for the 118 elements that we have. And the periodic table is divided into groups and period. So the vertical column is the group, while the horizontal row is the period. So we have group 1 to group 8, group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. And then we have the period 1, 2, 3, 4, 5, 6, 7. So one important thing to be noted here is that the oxidation number of metals, especially those in group 1, group 2, and group 3. The oxidation number of elements in group 1, group 2, and group 3 is equivalent to a group number. And so hydrogen will have an oxidation number of +1 because it belongs to group 1 of the periodic table. Lithium will have an oxidation number of +1. Sodium will have an oxidation number of +1. Potassium will have an oxidation number of +1. So all the elements here, their oxidation number is equal to +1. Then for the elements in group 2, the oxidation number is equal to +2 because they belong to the group 2 of the periodic table. So beryllium will have an oxidation number of +2. Magnesium will have an oxidation number of +2. Calcium will have an oxidation number of +2. Also, elements here, group 3, they have an oxidation number of +3. So boron will have an oxidation number of +3, aluminium +3, and so on. So these block of elements, they are known as transition elements, and they have different variable, they have what we call variable oxidation states. They have different oxidation state. The oxidation state is not fixed. So therefore, back to the question. So the oxidation number of iodine in potassium iodide is, the oxidation number of iodine in potassium iodide is, so like what we've explained before, that from rule 3, it says that the oxidation number of the sum of the oxidation number of all the elements in a compound is equal to 0. So that means that the oxidation number of potassium plus the oxidation number of iodine plus the oxidation number of 3 atoms of oxygen is equal to 0. The sum of the oxidation number of all the elements in the compound is equal to 0. So the sum of the oxidation number of all the elements in this compound, potassium iodide, is equal to 0. So having written this out, the next question you want to ask yourself is, what is the oxidation number of potassium? So like we've discussed before in the periodic table, that for group 1, 2, and 3, the oxidation number of the elements are equal to the group number. So if you look at the periodic table very well, potassium is in group 1, is a group 1 element, and so it will have an oxidation number of +1. So therefore, the oxidation number of potassium in this compound is +1. So potassium is having an oxidation number of +1. So instead of me to write the potassium here, I will write down the oxidation number of potassium. So potassium is +1, but I'm not going to write +1, I'll just write 1. So 1 plus, this is iodine, and we are looking for the oxidation number of iodine in this compound. So I'm just going to write I here to symbolize the iodine. Then plus, what is the oxidation number of oxygen? So if you look at rule 5, although we have not gotten here, we're going to explain this. The oxidation number of oxygen is -2 except in peroxides where it is -1. So the oxidation number of oxygen is always -2 except in peroxide, and this compound is not a peroxide. This is an ordinary compound. And so the oxidation number of oxygen in this compound is -2. So plus bracket -2, then we have 3 atoms of oxygen here times 3 equal to 0. So having written it out like this, we now have 1 plus iodine plus -2 times 3 will give you -6. So we have -6 is equal to 0. So this will be 1 plus iodine. Minus times plus will give you minus. Plus times minus will give you minus. Minus times plus will give you minus. So this plus times this minus is equal to minus. So -6 is equal to 0. So having written this out like this, we can now collect like terms. Iodine cannot be added to 1, it cannot be subtracted from 6. So we'll take the numbers to this side of the equation. So when 1 crosses to this side of the equation, it becomes -1. So this will be iodine is equal to 0, which is this 0, -1. When this 1 crosses, it becomes minus. And when this -6 crosses, it becomes plus. So plus 6. So iodine is equal to 0 minus 1 is -1. -1 plus 6 will give you plus 5. So our answer is therefore plus 5. So the oxidation number of iodine in this compound, potassium iodide, is plus 5. So our correct answer to this question is option C. Okay, let's look at one more example. Calculate the oxidation number of carbon in calcium triazocarbonate 4. Calculate the oxidation number of carbon in calcium triazocarbonate 4. So we have option A is +4, option B +3, option C +5, then option D +6. So we have to calculate the oxidation number of carbon in this compound CaCO3. So like we said before, that the oxidation number of elements in group 1, in group 2, and in group 3, they are equal to the group number. So the oxidation number of elements in group 1 is +1. The oxidation number of elements in group 2 is +2. The oxidation number of elements in group 3 is +3. So having known this, from the question again, calculate the oxidation number of carbon in this compound. So like what we said before, that the oxidation number of all the elements in the compound is equal to 0 according to rule 3. So by applying that rule, calcium plus the oxidation number of carbon plus the oxidation number of 3 atoms of oxygen will be equal to 0. Why is this like this? Because the sum of the oxidation number of all the elements in a compound is equal to 0. So the sum of the oxidation number of calcium plus carbon plus oxygen, everything in this compound is equal to 0. So the question you want to ask yourself is, what is the oxidation number of calcium? So calcium is an element in group 2. This is calcium, Ca. So as an element in group 2, it will have an oxidation number of +2. So the oxidation number of calcium is +2. So we have 2, which symbolizes the oxidation number of calcium, plus the oxidation number of carbon, which is what we're looking for, C, plus the oxidation number of oxygen. Like we've said before, is that the oxidation number of oxygen is -2 except in peroxide, and this compound is not a peroxide. We're going to look at what peroxides are in the next video. So the oxidation number of oxygen in this compound is -2. So we have bracket -2 times 3 atoms of oxygen that are in this compound times 3. So everything equal to 0. So this will be 2 plus carbon plus -2 times 3 will give you -6. So bracket -6 is equal to 0. So this will be 2 plus carbon, plus times minus will give you minus. So this will be -6 equal to 0. So having written it out like this, we can now collect like terms. Let the numbers go to one side and let the alphabet be alone. So this will be C is equal to 0, which is this 0. When this 2 crosses to the other side of the equation, it becomes -2. So this will be -2. When this -6 crosses to the other side of the equation, it will become +6. So this will be +6. So my C now, which is a carbon, is equal to 0 minus 2 will give you -2. -2 plus 6. -2 plus 6 will be equal to 4. So the oxidation number of carbon in this compound is 4 plus 4. So we have to calculate the oxidation number of carbon in this compound, calcium triazocarbon 4. So the correct answer to this question is option A, +4. In the next video, we'll continue with rule 4 and rule 5.